Hi, welcome to the fifth and I hope final part of the Exam 3 test review. Practice test, whatever this is called. Okay, number 17 asks us to find the area under the graph of g over the interval -2 to 3. So that's tricky because g changes what kind of graph it is at 0. Let me sketch this. Don't worry, just a quick sketch. So x squared plus 4 looks, approximately like this. And then 4 minus x looks approximately like this. So it actually has kind of a strange shape. We want this area. But all we're using is the fact that we can divide the integral up. So here's how I'm going to do this. Integral from -2 to 3 of g of x dx is equal to, I can go from -2 to 0 of g of x dx, and then I can add the integral from 0 to 3 of g of x dx. Okay, now from the -2 to 0 part, I'm less than 0, so I can use this definition, x squared plus 4. And for the 0 to 3 part, I'm above 0, so I can use this 4 minus x. Okay, antiderivatives, 1/3 x cubed plus 4x. And I'm going from -2 to 0. And my next guy is 4x minus 1/2 x squared. And I'm going from 0 to 3. Okay, so here I have to do 0 first, and then -2. We always start with the top. So 1/3 0 cubed plus 4 times 0, that's just 0. So for the first guy, I get 0 minus, and then I put -2 in. 1/3 -2 cubed is going to be -8. 4 times -2 is going to be -8. A lot of 8's running around. And that's my first integral. Now my second one, first I plug in 3. 4 times 3 is 12. 1/2 3 squared is 1/2 of 9, so that's minus 9/2. Then minus, and I need to put 0 in, but that's going to give me 0, so I'm not going to worry about that. So this is, okay, 1/3 times -8 is 8/3. So I have 8/3, the negative and negative cancel, plus 8, plus 12, minus 9/2. Eight-thirds plus 8 plus 12 minus 9/2 as a fraction is 109 over 6. Great, done. Okay. Number 18 asks us to find the area of this fancy shaded region that's between f and g. So g is on the top and f is on the bottom. You can either subtract them. You can either do it like this. The integral from, okay, so my x's are -1 and 4. Those are the points where the functions cross. I can either do -1 to 4 of g of x dx minus integral -1 to 4 of f of x dx, but that seems like a lot of extra work, so I'm going to instead do it like this. -1 to 4 g of x minus f of x dx. It's guaranteed to be the same. So that's -1 to 4 of x plus 28 minus x to the 4th plus 8x cubed minus 18x squared dx. Notice when I subtracted, I distributed that subtraction, so that's how I got a plus here and a minus here. Alright, doing my antiderivatives, I get 1/2 x squared plus 28x minus 1/5 x to the 5th plus, okay, I'm going to have x to the 4th. I have to divide by 4. 8 divided by 4 is 2. So 2x cubed. Here I get x cubed. I have to divide by 3. 18 divided by 3 is 6. And you do that from -1 to 4. Okay. Stay with me. We can do this. 1/2 times 4 squared is 8. Plus 28 times 4 minus 1/5 times 4 to the 5th plus 2 times 4 to the 4th minus 6 times 4 cubed minus -1 squared is 1, so that's 1/2. I'm going to get minus 28 plus 1/5 plus 2 minus 6, no, plus 6. Put this in your calculator. I got 62.5. Hopefully I typed everything in correctly. Okay, next page. Okay, I think we're on the last problem. It's an absolute value. So here's the thing we need to remember. Alright? The absolute value of x, one way to write it is as a piecewise function. It's equal to x when x is not negative, and it's equal to negative x when x is negative. Probably should have reversed those to put them in order. So absolute value of x minus 3 is equal to, I'm going to put the negative x on top so my things go in order. Negative x minus 3 is reversed, 3 minus x, when x minus 3 is less than 0. And it's x minus 3 when x minus 3 is greater than or equal to 0. So let's figure that out. X minus 3 is less than 0. We add 3 to both sides. That gives us x less than 3. X minus 3 greater than or equal to 0 is when x is greater than or equal to 3. We're just adding 3 to both sides. Okay, so that tells me x minus 3. I'm just setting this up to make it as easy as possible for myself. Is 3 minus x when x is less than 3. And it's x minus 3 when x is greater than or equal to 3. Okay, so this integral, I'm going to split it up at 3, just like I did the other piecewise function. Oh, sorry, forgot my other part. I, of course, need the integral from 3 to 4. Okay, so from 0 to 3, that's less than 3. So 0 to 3 of 3 minus x dx plus the integral from 3 to 4 of x minus 3 dx. Okay, now we just broke it down to integrals. Everything's good now. So this left one is going to be 3x minus 1/2 x squared, evaluated from 0 to 3. And this one is going to be 1/2 x squared minus 3x, evaluated from 3 to 4. My zeros are turning into some weird letter here. Okay, so this left guy is 3 times 3, that's 9. Minus 1/2 3 squared is 9 halves. When I plug 0 in, I'm going to get 0, so I'm leaving that alone. 1/2 times 4 squared. 4 squared is 16, so 1/2 is 8. Minus 3 times 4 is 12. Minus, now I've got to put in 3. I've got 9 halves again. Minus 9. So overall, I have 9 minus 9 halves plus 8 minus 12 minus 9 halves plus 9. I'm putting this in my calculator. 9 minus 9 halves plus 8 minus 12 minus 9 halves plus 9. I get 5. That's it. If you made it this far, congratulations. You are a trooper.